presentations. You did amazing job. I will talk about my project Deki. It's a vision-based Android agent. Deki is mostly about generating description of the UI screen, but also you can use it for creating Android AI agents. I will show the demo of the Android agent. I have two phones where Deki is running. First phone has like command go to LinkedIn, tab post and write hi it's Deki and now I'm multi-threaded. But don't post, just return to home. And the second is about opening the browser and say what's on the page. The server which runs Deki is on my computer, so it's not a special hardware, but it works quite fast. And as you see, the second phone is already the second agent already finished its job. And the first one also. Like several days ago, I just enabled the functionality to run Deki fully locally on device without internet access, without like connecting to like running the large language model or object detection model on the computer or other server. It's just I will show just a demo of the local AI agent, Android AI agent. I used geometry n with 4 billion active parameters and int4, like 4 bits per integer and float. So I'm sending the request. There's an object detection model that runs there. And also you can see the prompt example that I have sent to the large language model. It's not a fine-tuned one, just a general, and just to check if Android AI agents can run on device. And the model is initializing here. The model is quite big, and it's a Samsung S23 Ultra, and of course for like better devices will have faster inference time, shorter. And inference now is happening. And LLM here responded that there's a reasoning part and action part, like open, com LinkedIn, Android. It's a package name on Android. And it just opened and yeah. So it works fully locally without internet access or etc. Most of the AI agents actually are sending requests via internet, but in general, it's like almost no one does every like processing on the phone. And yeah, I will talk about 3 topics, like the semantic gap, the challenge of translate complex UI screens into low-level computer-readable data, computer-readable low-level data usage, about using the generated data for task automations and code generation, and one solution for all platforms. Like this model should work on iOS, on Android, on Windows, macOS, Linux, and etc. Because we don't have much time, I will just go very fast. The main idea of like Deki is that large language model in general lack precise information about coordinates and sizes of some objects, and it's essential to augment them with object detection for vision-related tasks. And Deki uses YOLO, model, CNN, OCR, image captioning, image enhancing, image parsing, other image parsing techniques, spell checking, etc. and etc. It analyzes UI screenshot and produces a structured JSON or TXT description of UI screen. So it's just an example of YOLO detection for sample app. And here we see that most of the elements are detected. We have only 4 classes, like view class is like container-like class. Image is UI, it can be UI icon or just a normal image of a car or a person. Text and line. And yeah, and YOLO accuracy, actually, it was trained on 486 images and was tested on 60 images. And why such a small amount image? Because actually creating like data set for AI agents is very hard because as presenter says that actually UI screens have like lots of UI elements and you need to annotate them manually like or in semi-automatic way, and it's actually quite hard, but accuracy is more than enough because it has like 83%. And but for production, maybe you will need to increase the dataset, training dataset, up to several thousands. I think that it will be enough. And after YOLO detections, JSON or TXT description is generated of all elements, and it's sorted by from top to bottom. And some attributes are extracted from all UI elements, like background color, alpha channel for view and line elements. For text regions, it's text itself, alpha, background, spelling checker, and image regions have like CNN to detect is it a normal image or UI icon, image captioning via Llama Vision or Blip 2, and JSON description of the UI screen is generated. Also, there's a possibility to generate TXT description. As you see, for example, there's a car, and it's a description of a car. Like it says just some card is there, phone, credit card, and other objects. Also for AI agents, they actually don't need such a long description. You can use JSON mini format to reduce token usage. It just has like image size, box format, center X, center Y, width and height, and ID, and if it's text, just the value of the text. So after that, set of mark prompting technique is applied. It's like you are taking input image and you are drawing bounding box around on top of that element, and you are writing the ID of this element. And when you will give this input image to LLM, you won't give the original one. You will give this one for LLM to link the object on the screen, on the visual input, with the text description. So actually, deki is image description model. It can be used for, I'm showing now graphical user interface agent, but also, of course, you can use it to generate the code from image, like you are giving the UI component, image of the UI component, and it will generate the correct code for it. So AI agents use case are mostly like about like writing to some friend on WhatsApp or writing Twitter post about something, but also, of course, you can use it in production. And some companies already are started to analyze it. And for example, when some Android build or iOS build of some application is sent to testers, to QAs, AI agent can open it and enter some page, travel through the app, and check if the application is like crashing. It's just a simple smoke test, but it's an important one. Also, of course, agent also can check the actual screen state with the desired screen state, and if the delta between two states is higher than threshold, it can report a bug. You can check the screen state by pixels or like other some other formulas. It depends on you, like structural similarity index or other formulas. Yes, and AI agents, as I said before, need only small JSON description. They don't actually need very long one because when you send the image to the LLM, you will use not the original one, but augmented image with IDs and bounding boxes. And it can link, for example, text one with a box with ID one. And actually, what differentiates deki from other agents, mobile agents, is that it does not use Android debug bridge. It only uses Android accessibility services, which makes it production suitable. Why? Because if you use Android debug bridge, you need to enable developer options on the phone. Also, you need to connect the phone to the computer. Also, you need to enable USB debugging there. And actually, it will create like some problems for some users. For example, if developer options are enabled, some apps are blocking these users. So it's not like production ready. Deki uses just vision and accessibility services. So it makes it production ready. And it only uses vision without accessibility tree information. So you can fine tune the model to work on iOS, on Android, on Windows, Linux, Mac, and other OS systems, OS, and without some OS specific accessibility tree. It will be much easier for you to do it. So some commands that Deki currently supports is like swiping. You are writing the start coordinates, swiping left, right, top, and bottom. Go home, go back, and open some application. It's WhatsApp is a package name in Android. Tab coordinates is X and Y, X and Y coordinates. Insert text, you are writing there X and Y coordinates and the text that you need to insert, and it can respond with answers like a screen is in a loading state, try again, or like can't proceed, finished. And why? Because sometimes when transition happens, some apps are in loading state, and if you use this screen to like if you ask LLM to do some action, if you force it to do some action, LLM can like produce the wrong output. And of course, the answer. If you are using the agent as a chat bot, let's say, it can give you just an answer without any actions. To improve accuracy and task completion speed, in the first request, Deki sends to the large language model the list of all non-system non-system application that are installed in the phone. And actually, in some cases, agent completes some tasks faster than human because of this. And for memory, deki uses reasoning like planning, like almost every other model does, agent does, and also small one-sentence description. Why it was added? Actually, when I was trying to evaluate the deki, I found that if I write the screen description in the history, and deki can analyze, the model can analyze the previous steps and to read what was on the screen at that moment, and uh, it will take better actions in the next steps. Um, the agent will not be trapped in the loop, and it improved the accuracy of the model when I added like screen descriptions to the history, previous screen descriptions. And I evaluated deki on Android control single step benchmark. So when you use, for example, there's a GPT-4o results for this benchmark. It got like 48% accuracy, but when you add their deki, like image description model, its accuracy improved, like it became 66.5. And if you use like better language model, of course, the core system, the core of this AI agent is LLM. It can get higher scores, like for example, GPT-4 and deki scored 70.7%. And for Android world benchmark, it's a multi-step benchmark that Google created. It's quite hard benchmark. It works on emulator, like on image or Android 14 OS image, and Google gives you all the environment, and you are only extending the base class that Google provided to you and write several functions to pass this benchmark. Deki with Gemini 2.5 Pro scored like 66.6, like successfully passed 66.6 tasks, and but it was evaluated on the subset of this benchmark, not the whole benchmark. And mostly, as you see here, agents actually are using accessibility trees, but for only vision-based model, it's quite good results. And as I showed before, like of course, ultimate goal of the AI agent on the phone is that to be able to run the whole pipeline on the phone without sending the screenshot information to the server or to the computer via USB. And for this, as I showed before, that I use Geometry M with 4 and 2 billions of active parameters. And of course, it has like lower accuracy than a computer model, like a big model, but for the like first step, it's quite good. So limitations. To make agent fully production ready, the agent should be fine-tuned. The model should be fine-tuned on agentic tasks. And also, for if you want to use agent on the device on edge, let's say, you need to have a quite good phone, high-end phone, because most of the models are quite big, and if you use them like several minutes, and they will heat up very fast, and it creates problems. After heating up, the model runs slower. And you need, of course, to fine-tune your YOLO model for the device, for the phone, for your phone, because the model, the YOLO model that runs on the phone has lower accuracy than an actual computer, like a standard model. Yeah, and of course, you can check GitHub. The whole code, like Android machine learning backend code, are open source. You can check it. Also, you can play with deki, just image description, UI screen description on the check it in Hugging Face space. You can check Analyze and Get YOLO tab. It works without API keys. And yeah.